Let us add or subtract as indicated. Assume that any variables represent positive real numbers. So, example A, 5 root 15 plus 2 root 15. And the first thing we should do is make sure those roots are simplified. So since 15 is 5 times 3, there's no square roots inside of there. So then we want to check, there's two separate terms separated by the addition, right? So two separate terms here. We want to see if they're like terms, if we have like radicals. So we have the same index, 2, and the same radicand, 15. So yes, these are like radicals. That means that we can add the numbers in front. So 5 plus 2 makes 7 root 15s altogether. In example B, we have subtraction that separates these two terms. And so let's look at the radicals, simplified as can be. Same index, 3, same radicand, 2y. So let's add the numbers in front. 9 minus 15 is negative 6, cubed root 2y's altogether. Example C, 6 root 10 minus 3 cubed root 10. So there's subtraction of two separate terms here. And I can't simplify the radicals, so do they have the same index? No. These are not like radicals. They don't have the same index. Even though they have the same radicand, it doesn't matter. It has to be both the same. So that means that I cannot add these together. They stay separate as they are, and that's the final answer. In example D, I've got subtraction, addition, so 3 different terms here. And they don't look like terms, but that's because I need to make sure that they're simplified first. So let me take that first radical. Root 20 is 4 times 5. So I do have two factors, because that's the index. I can take the root of those two, and that leaves 5x inside. Then this middle term, there's already a negative 6 in front. And then 16 is 4 times 4. So that means we do have 4 that we can bring out. So that's going to multiply with the negative 6, making that negative 24. And all that's left inside is x. Then this last radical, let me go the other way, this way. There's just a plus sign in front, and 45 is 9 times 5. So we do have a square root of 9, which is 3, and 5x is left inside. All right, now all of these are simplified, and we do have like radicals here with the square root 5x, so I can add the numbers in front. 2 plus 3 is 5 root 5x's, and then that middle term just stays as it is to simplify this expression here. More adding or subtracting, and variables are positive real numbers only. And that's so we don't have to worry about the absolute value, right? It doesn't matter. So E, we have cubed root of 8y to the 5th and another cubed root separated by the addition, but they don't look like they have the same radicand. So let's simplify what we can first. So the cubed root of 8 is definitely going to be 2. What about y to the 5th? I prefer to look at that as a rational exponent because 3 goes into 5 one time, and then there's 2 left over. So 1 time with 2 left over out of 3. So that means that there's still a cubed root of y squared left inside the radical. So that's the first term. The second term, there is a cubed root of 27 because that is 3 times 3 times 3. The cubed root is 3. And then y to the 5th, again, I have to look at that as a rational exponent. 3 goes into 5 one time with 2 left over, 5 minus 3. So that'll be a cubed root, that's the denominator, of y squared left over. So now I have these two terms, and oops, I forgot the y outside, this y. They are both y cubed root y squareds, so I just add the numbers in front. 2 plus 3 is 5y cubed root y squared. So all of this has to be the same, and it is, to simplify to this expression. F, well, that looks interesting because we got fractions now, so a lot of stuff to worry about here. Let's first say this is subtraction, so these are two terms here. And they have radicals in the numerators, but they're not the same radicals. So let's see if we can simplify the square root 75. Just going to isolate that first and look at that. So 75 is 5 times 5 times 3. So we do have a square root of 25, which is 5, and then there's 3 left over. So let me rewrite this here. 75 becomes 5 root 3 over 9. And the other parts stay the same. Okay. Whew. So we do have radicals in these two terms. They're like radicals, which means I can combine them, but they're fractions as well. So I cannot combine these two terms until they have the same denominator. So the least common denominator of 9 and 2 is 18. So that means I need to create equivalent fractions. That means that 9 needs to be multiplied by 2, and 2 needs to be multiplied by 9. Well, we must multiply the numerators as well. So for the first term in the numerator, 2 times 5 is 10 times root 3 over 18. And in the second term, this 9 is not in a radical, so it's going to multiply to the front, 9 times root 3 over 18. And now that they have the same denominator, yes, I'm talking about 18ths. My difference will be 18ths. I'm just going to subtract the numerators. So 10 root 3 minus 9 root 3. And those are like radicals, so I can subtract the numbers in front. 10 minus 9 is 1 root 3 over 18. So just root 3 over 18 will be perfect. That does not simplify because this factor of 3 is under the radical, and this factor with 18 is not under a radical. So they are completely separate. I cannot simplify that at all. It is already simplified. For G, we've got cubed roots that we're adding together. So two separate terms here. They don't look like the same cubed roots. Let's simplify the first term. So I'm going to use the quotient rule to separate the radicals. So cubed root of 5x over cubed root of 27. And then I can simplify the denominator, because the cubed root of 27, that's 3 times 3 times 3, so the cubed root is 3. And well, that's all I can do. So let me write the rest of this. And let's see if we can add these together. Cubed root of 5x, cubed root of 5x. I can add them together, right? But one of them is a fraction, so both of them must be fractions. Then I need a least common denominator for 3 and 1, and that'll be 3, which the first term already has, cubed root of 5x over 3, that's perfect. But this fraction needs to have that in the denominator. So let me just create an equivalent fraction with 3 in the denominator. So we need to multiply by 3 to get there. And remember, when we multiply, these 3's are not under a radical. So they're multiplying as a coefficient. So 3 times 4 is 12 cubed root 5x's. The radical doesn't change unless it multiplies unless there's an operation with another radical. Okay, so an equivalent fraction here of 12 cubed root 5x over 3. Now that these have the same denominator, I can add them together over that denominator. So a cubed root of 5x plus 12 cubed root of 5x. I'm just going to add the numbers in front. 1 plus 12 makes 13 cubed root 5x's over 3. And this would not be the end of this. We'd have to make sure we could not divide these factors that are not in a radical. But 13 doesn't divide by 3, so that is as simple as that gets. That's our simplified sum.